Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we will study about the arithmetic instructions available in the 8051 microcontroller. So let us start with our topic. In 8051 microcontroller, we have the instruction set. In the instruction set, we have different types of instructions which perform various types of operations like arithmetic operations, logical operations, data transfer operations. So depending upon the type of operation performed by the instructions, they are classified into different categories. So the 8051 instruction set, it is classified into 6 categories. First is data transfer instructions. So these are the 6 categories into which all the instructions of the 8051 microcontroller, they are classified. In this video, we are going to study the arithmetic instructions of the 8051 microcontroller. These arithmetic instructions, they perform the arithmetic operations like addition, subtraction, multiplication, division, increment and decrement. So all those instructions which perform these arithmetic instructions, they come under the category of arithmetic instructions. So we can say that they can perform division, increment and decrement on 8-bit numbers. Okay, so this is the definition of arithmetic instructions. First, we will start with the instructions which can perform the addition operation. Now addition, for addition we require two numbers. Okay, so we will have two 8-bit numbers and the result of that addition will be stored in one of the registers. So here we will require two operands. One will be the two operands are there. One operand will be stored in the accumulator and another operand, it can be an immediate data, means directly the data will be given in the instruction. So it can be an immediate data or it can be a register or it can be a memory location. So we require two 8-bit number. One 8-bit number will be in the accumulator and one 8-bit data. Either it will be the immediate data or it will be stored in the register or that the memory location. So these two numbers, they will be added and the result will be stored in the accumulator itself. Okay. So destination will always be the accumulator where the result of the addition is stored. Now in this category, addition category, we have three types of operation. First is to add the contents of accumulator. With or without carry. Now when these two numbers are added, they can be directly added, means two 8-bit numbers are added, result is stored in accumulator. Also along with these two numbers, we have the carry flag also. Now if carry flag is used for the addition, then we say that this addition is with carry. Okay, and when carry flag is not used, then we will say that we are adding without carry. Okay, now carry flag, it can have two values, either it will be 0 or it will be 1, means either it will be reset or it will be set. So depending upon the status of the carry flag, the addition will take place and the result is stored in the accumulator. Example of this is, because here we are adding the contents of A with the immediate data. So data is available in the instruction itself, 45H. Immediate data, we will use the asterisk hashtag sign here. Hashtag sign is written. So this is the immediate data 45 and one number is stored in the accumulator, one 8-bit number. Those will be added and result is stored in accumulator. So this is addition without carry. If we are using the carry, so we will have A, B, D, C. C is for the carry. So mnemonic will change. ADD is for without carry and ADDC is for with carry. One of the operand will be in the accumulator and another operand will be the 8-bit data. Okay, so this is addition without carry and this is addition with carry. Next type of addition is add the contents of A with the register, again with or without carry. Example of this will be without carry, add the contents of A and a register Rn. This register can be any of the 8 registers of the 4 register banks in 8051. In 8051 we have the 4 register bank, bank 0 to bank 3, and in these banks we have 8 registers. So from R0 to R7, any of the register from the 4 register banks, bank 0 to bank 3. Okay, so add A comma R5. So 5th register of the selected register bank will be added with the accumulator without carry. If we are using carry, so ADDC will be the mnemonic and A comma R2. So here register and accumulator are added. Third, we have to add the contents of accumulator with memory location, again with or without carry. So example of this will be ADD A. Directly we are writing the address of the memory location, so they will be added. With carry, if we are adding, so ADDC A comma 75H. So this is with carry, this is without carry. Now this is the type of direct addressing. If we are using indirect addressing for the memory, we can have ADD A, address of the memory location is in the R1 register. If we are doing it with carry, address of the memory location is in the R0 register. So this type of addressing is the indirect addressing. So in addition, we have 3 types of addition. Addition with the immediate data, addition of accumulator with the register, or addition of accumulator with the memory location. And in these 3 types, we have with or without carry. In the case of memory, we can use both direct addressing and the indirect addressing. In indirect addressing, we use this symbol. So the address of the memory location, it is stored in some register. Okay, indirectly the address of the operand is given. Here directly the address of operand is given. Okay, So this was about the addition. Now whenever the addition operation is taking place, the flags of the microcontroller, they will be affected. Like carry flag will be affected if carry is generated, auxiliary carry flag is affected if auxiliary carry is generated. Also overflow flag is generated when there is an overflow in the result. So due to this addition operation, carry flag, auxiliary carry and overflow flag, all these three flags are affected. Okay. Now comes to the next instructions category in the arithmetic. We have the subtraction instructions. Now just like addition, for subtraction also we will require two 8-bit numbers, and it can also be with or without carry. Here carry doesn't means that the number is greater than 8 digits. Okay. Borrow, in the case of borrow also, when we are subtracting a larger number from a smaller number, we have to take a borrow. Okay. So in this case the carry flag, it is treated as a borrow. Okay, in the case of subtraction. So here we will say that with or without borrow, or we can say with or without that carry flag we are doing the subtraction. Now here subtraction, one operand will be in the accumulator and another operand, it will be either an immediate data, or it can be a register, or it can be a memory location, just like the addition. Okay, so first we will have contents of A. Again I am telling that carry flag, it is the borrow. Okay, in the case of subtraction. Examples of this are, the mnemonic for subtraction is SUBB. Okay, subtracting the contents of A with the immediate data. Okay, then again SUBB A, comma immediate data 0 B4 H. So here immediate, the data 8-bit data, it is given in the instruction itself. Second type of is when we are subtracting the contents of A with the register. Here also with or without carry we can use. So SUB A, comma R5, SUB B A, comma R2. Okay, so with or without carry we are subtracting the contents of the register R5 and R2 from accumulator. Result is stored in the accumulator itself. Third, we have with the memory location. Again we can use direct or indirect addressing for this. So examples will be directly address is given, indirect addressing, okay, the address of the memory location is stored in the R0 register. So this is direct and this is indirect. So for both addition and subtraction, one of the operand will be in the accumulator, and we are using the carry flag also. With or without carry also we can perform these two operations. And the another operand, it can be an immediate data, it can be a register, or it can be a memory location. Next instruction, arithmetic instruction, are those which perform the multiplication. Now for multiplication also we will require two 8-bit numbers. multiplication, we have only one instruction, MUL, A and B. Okay, so this is going to multiply the two 8-bit numbers which are stored in the accumulator A register and the B register, and the result is stored in the accumulator. So this instruction MULAB, it is going to multiply two 8-bit unsigned numbers, means the number is not going to be a negative number. Unsigned number we are using, and one number is stored in accumulator, another number is there in the B register. So when these two numbers are multiplied, two 8-bit numbers, the multiplication will be greater than 8-bit. Okay, so after multiplication, the lower byte of the result, that will be stored in the accumulator, and the higher bytes of the result, they will be stored in the B register. Okay, because when two 8-bit numbers are multiplied, their multiplication will be greater than 8 bits. Okay, so it will have 16-bit number. So lower byte is stored in accumulator and higher byte is stored in B register. Let's take an example here. First, we are moving in accumulator a number, that is 45H. Then in B register, we are moving the next number, that is 0F5H. And then we are multiplying A and B registers. So A is having 45, B is having F5. When they are multiplied, the result is 4209. Okay, so in this, the lower byte, that is 09, will be stored in accumulator, and higher byte is 42, so B register will have 42. So in this way, when two 8-bit numbers are stored, we will get the complete answer in the A and B registers. So that is multiplication. Next, we have the division. Now for division also, we will require two 8-bit numbers. Okay, now here the 8-bit numbers, they are stored in A and B registers. Okay, they are divided. So just like multiplication, we have the division D, I, V, A and B. Okay, A will have the result and B will have the remainder. So when two numbers are divided, we will get a result, and second we got a remainder. So A and B will have the two operands, two 8-bit numbers. After the division, the result will be stored in the accumulator, and the B register will have the remainder. Let's take an example here. Again, we are having A is having 45 and B is having 0F5H. We have to divide these two numbers, so we will write DIVAB. So when A is divided by B, that means 45 is divided by F5, we will get the remainder as 10H, and result is 08H. So result will be there in accumulator and remainder will there be in B. So collectively we'll get the total result in A and B registers. So this is how the division instruction is executed. Next instructions we have in the arithmetic instructions category are the decimal adjust accumulator. that is the DAA instruction. DAA full form is decimal adjust after addition. Now, if we want to use the BCD addition, okay, in 8051, if we want that two BCD numbers are added, then when two BCD numbers are added, the result is a non-BCD numbers. Now, if we want that the result is also a BCD number, then we will use this DAA instruction, okay. So whenever BCD operation is addition is done and we are having a non-BCD number, if we want to get a BCD result, we use this DAA instruction. So what this DAA instruction does, it checks that if the lower nibble, because we are having 8 bits, 8 bits can be divided into 4 bits, so it will be the lower, a group of 4 bits is called a nibble. So lower nibble and upper nibble, okay, that is from D0 to D3 and from D4 to D7, okay. Now if this lower nibble, that is D0 to D3, it is greater than 9, okay, then auxiliary carry is generated. Auxiliary carry means the carry which is generated from D3 to D4 bit. If this D0 to D3 it is greater than 9, then carry will be generated. That carry will be called the auxiliary carry. So 6 is added to the lower nibble, and when in the upper nibble it is greater than 9, that is a carry will be generated from the D7 bit. So 6 is added to the upper nibble. So this is how we will get the result, which is a BCD number, okay. Let's take an example for it. So here we have moved two numbers into A and register R1. A will have 23 and R1 will have 55. These two numbers will be added. So what we will get? 538, 567, 78 we will get. Now this is a simple addition, okay. So the accumulator, it will have the contents 78, and when this instruction DAA, because lower nibble is also less than 9 and upper nibble is also less than 9, so no changes will be taken place in the contents of the accumulator. Accumulator after this D instruction, it will be 78 only, okay. Let's take another example. Now this time A is having 53 and R1 is having 58. So when they are added, 8 and 3 it is 11 and 5 and 5 it is 10. So here we are getting 10 and here we are getting 11. Both these numbers are greater than 9. So what this DA instruction, that is DAA, it is going to done. After this instruction A accumulator, it will have, for 10 it will have A and for 11 it will have B, okay. That is the result in the accumulator. Now when this DAA instruction is executed, the new contents of the accumulator will be 1 1 and carry flag it is 1. How? 8 and 3, it is 11. Okay, so 1 is written here and 1 is taken as a carry, auxiliary carry. Again 5 and 5, that is 10, and plus 1 carry is there, so 11 is there. So 1 is here and 1 is taken as the carry. So 53 and 58. 8 and 3, we are having 11, 1 is there, 1 is taken as carry. 5 and 5, 10, plus 1, 11 is there, so 1 is written here and 1 is taken as carry. So result, after this DAA instruction, we will have 11 and carry flag is set. So this is how the decimal adjust after addition, that is done to obtain a BCD number. Okay. Next instructions in arithmetic category, we have increment and decrement. These numbers are used to increment or decrement the contents of the operand by 1. If we want that, suppose accumulator is having 23. If we want to increment it by 1, then new contents will be 24. Okay, just like if we want to decrement, like if contents are 25, then we are decrementing it, so new contents will be 24. So increment and decrement instructions are there. Which decrements the operand by 1. Now this operand, it can be accumulator, it can be a register, it can be a direct memory, or it can be an indirect memory. Examples of this are increment, we use the mnemonic INC, and for decrement we use DEC. Okay. Now increment, it can be INCA, or it can be INC, any register is there, or it can be INC direct address is given, like 54H is given, or it can be indirect like INC, we have the register here. Okay, indirect addressing can also be there. Similarly for decrement, we have the accumulator, we have register, we have direct memory, or we can have indirect memory. Okay, always increment and decrement by 1. Just remember this. Now when we are incrementing, suppose we are incrementing from 0 0 to FF, okay, so when the number is FF, when it is incremented by 1, again it reaches to 0 0. So increment and decrement, when we are doing, like if suppose we are incrementing the number FF and we are adding 1 to it, it will again come back to 0 0. Okay, so again it is coming like 0 0 0 1 0 2, again it is start incrementing from it. Again like in the case of decrement, if we are decrementing the number 0 0, so decrementing it by -1, it will come back to FF. Okay, now these conditions, when we are again starting from the initial value, that is called the rollover. Okay, in this case also, when we are incrementing from the maximum value, we are getting again the minimum value, again initial value we are starting from here. If we are decrementing less than that minimum value is 0 0, we are decrementing it, so again we are starting from the final value. Okay, so this condition is called the rollover, and whenever this condition is achieved, the carry flag is not set. Okay, so whenever rollover condition occurs, the carry flag is not set due to this increment and decrement. In this case, it is from 55, FF means 255 to 0 0, and here from 0 0 to 255. Okay, So these are the increment and decrement instructions which come under the category of arithmetic instructions. So in this video we studied about the arithmetic instructions available in the 8051 microcontroller. We studied the addition, subtraction, multiplication, division and increment and decrement instructions. So I hope that this topic is clear to you. Thank you.